This is Britt Caswell with another example video. In today's video, I'm covering example 5 from lesson 5-5 in the SavvasRealize Algebra 2 textbook. The goal of today's video is to write a rule for a composition function. Alright, so we learned in our last video that composite functions can look like this. This is read as f of g of x. Now sometimes people don't like this notation. Sometimes there's another type of notation, which appears here. This is saying to find f of g of x. Alright, this dot is not multiplication. Okay, f of g of x is not the same thing as f of g of x. Alright, those are whole other ball games. So this one is saying to multiply, and this one is saying to compose, which means to plug g of x into f of x. Okay, so just be aware of that notation. That's why I don't care for this particular notation. I like the parentheses. But let's do it anyway. So for example A here says to find f of g of x. So this is saying to take g of x and then to plug it into f of x. And so that's what I'm going to go ahead and do. So for notation's sake, here's my equation, and I'm going to write out f of x and leave a space with parentheses to plug g of x in there. And then, just like my turducken example, I am tucking that 2x minus 5 in there. And now I need to kind of simplify that a little bit if I can. Alright, so here I can actually drop the parentheses, they're not necessary. And negative 5 plus 7 is 2. And that's about as far as I could take that example. Alright. So now sometimes plugging them in can be quite a pain in the neck. So here my f function has a squared term and a linear term that I'm going to have to plug g of x into. And so what that's going to do is that's going to create for a very long, hideous equation. Okay, so again I'm going to write out the f function, leaving spaces where the x's are to plug in the g function. And then I go in with that 4 minus x and put it in here. Alright, now we don't like having all these parentheses around, so we have to simplify those. Alright, so the 4 minus x I need to multiply times itself. Oops. And then I'm going to go ahead and distribute this stuff out real quick. The 4 and 2 combine to make a 6. So that wasn't so bad. So now just changing colors so you guys see what I'm doing here. I am multiplying these bad boys together, and I get 16 minus 8x plus x squared. Okay, if you need to go to the side and do all your steps, go to the side and do all your steps. I didn't leave much room, to be honest. And then our last step, we want to write it in standard form. So standard form, right, you want to make sure that your exponent, the highest exponent, goes first, and that all your like terms are combined. So the negative 8 and the negative x here, they come together, and the 16 and the 6 come together. And there we have it. So that is our composed function. Now on this one, they actually want us to compare f of g of x and g of f of x. So they want us to compare them both. Okay. Now on this one, because I have an x cubed, I probably won't be doing as much expansion. Like you could turn it into binomial expansion, right? I'm lazy though, so I'm not going to quite do that. So first let's find f of g of x. So that's saying to take the f function and to plug the g function into it. And I'm just going to leave it as that. I'm not going to go hog wild there. So now our second one is now saying to do g of f of x. And so this is saying to start with the g function and then to take the f function and to plug it in there. Do you kind of see that difference? Now here I don't need the parentheses, so I'm actually just going to get rid of them. So notice those are completely different functions. Alright, now to do it here for part B. Okay, so my f I'm going to color blue again. G I'm going to color red. So when I go to find f of g of x, in this one, because it's only squared, I'm probably going to do my distribution. It's when you get the higher exponents that textbooks and tests tend to be a little more lax. They're like, you don't have to deal with that cubic, it's fine. But whenever you have something squared, they will generally demand that you expand that. So if I do expand that, I get x squared minus 10x plus 25. Don't forget that plus 1 comes down. So my final expression here for f of g of x is x squared minus 10x plus 26. Okay. Now I'm making some straight lines so you guys know there's a break here. And now I'm going to solve for g of f of x. And this one should be a little bit easier, just because g of x doesn't involve any squaring. And for that we rejoice. Okay, so I have plugged f into g. And so here I could just drop the parentheses and collect those like terms. And there's my g of f of x. So there we have it. There's a few more examples of writing a composite rule. Until next time.